Well, this is Old Electronics Fan, and my original goal was to align this so that it's accurate enough so I don't need to have a frequency counter connected to it. And, well, it didn't work very well. So, I have all these components that I took out of there. Resistors were not great. And just looking at this, I put in these two capacitors, which I knew they weren't high-end, but I thought I'd try them anyway. The other thing about this is that I puzzled about, if I could talk, it'd be really helpful, is this is Illinois capacitor, 100 microfarad, 18 working volts DC, SMTMO, whatever that means. It's got a part number, I don't know if that's part of it, and then it says J9-65, so that could be the date on, oops, darn. Alright, looks like 965 could be a date. 9001, I don't know what that means. 022-032, I assume is a part number. SMTMO, I don't know what that is. This is identified in the parts list as an electrolytic capacitor. This is sealed. It's a plastic case, but this I can't. All right, I cannot. I should probably see if I can find anything about this. This looks like a paper capacitor, but it's apparently not. It doesn't look like an electrolytic. But this size capacitor can't be paper or anything like the paper. So, what's this one? This one is 10 microfarad. Okay. So, this is 100, this is 10. But anyway. Oh, there. Here's the problem I've got. Let's back out so you can see what's going on here. It doesn't show up, well, kind of does. This is worse than it was before I worked on it. And I have a feeling that the problem is these. Let's go up here. So these need to come out and these need to get put back in. I wanted to replace this because instead of being I wanted to replace this because instead of being 100, it's reading 150. I'm pretty sure that's what it was. Let me remind myself. And why not? We'll do an ESR test as well. Let's see. We want, that's supposed to be that. Okay. This does have polarity on it. That also, I just noticed there's little pluses on it, so it does have polarity, which implies that it's electrolytic. So, I'll be honest, I've never seen one of these, but, man. Well, 153, and you can't see it. All right. Just so I can get everything in view. Come on. All right. It was saying 154 just a minute ago. Come on, you. Let's go. Well, it's changing its mind as it goes. Why? Why are you not doing stuff the way I want you to? Well, anyway, it was saying 154 a minute ago. Well, alright, so that's not a good indication. Let's check this one out. This is supposed to be 10, and we'll do ESR in a minute. Well, $13, so this one's high as well. Well, let's check our ESR and see what we got. Alright, because I want to zero this out. Okay, now let's go to ESR 5, and this should be, how many volts? Or 16. So 10 at 16, 8 is 8 for is the highest number. Therefore, this actually ESR wise is fine. Let's go over here. This is 100, and check this out. And that's 0.9, and this is 100, and this was 18, I think it said. So 100 at, well, between 16 volts is 0.7 and 25 volts is 0.3. So this one, ESR, is a bit higher than it should be. So this is not entirely healthy. And I should look at, did I not dig that out? Yeah, okay, here it is, I think. That's not what I want. Okay, stay for a minute. I have a schematic somewhere, and I want to look at this and remind myself. Okay, radio analyst. Okay, I gotta find my, where are you? Alright, so here's my circuit diagram. I just wanted to see something. I thought this was in line with this circuit. That's what I was remembering, which is why I wanted to look at this again and make sure that I had this right. As it turns out, I did not. This is the pi circuit, and this is a pi circuit. And there's that 100 microfarad 18 volts. So this is filtering. And this is probably the first place I should start as far as where this problem is. I'm betting that this inexpensive capacitor is going to be causing problems with filtration. Is allowing that signal to dance. That's what I'm guessing. If it's not that one, then I'm fairly sure. Let's see, how many of these do we have? I don't think we have. Okay. Alright, so I'm just looking quickly through here. That's a picofarad. 001. 001. That's resistor. 001. Yeah, none of these are. That's a 0.1 at 05 and 05. That's a 10. That's picofarad. And That's a picofarad. Now this is, I believe, a coupling cap. It's high frequency. It's 400 picofarad, so it's fairly high. So that's keeping DC, any DC out here coming back in here. This is rated at 400 volts, and they tell you in the manual that if you're coupling up to anything that's higher than 400 volts, then you need to put in another capacitor in the circuit that will handle the higher voltage. So anyway, so I've got this one and I've got this one. And if I were to guess which one is the problem child, I would say it's this one. I'm trying to always remember that I should English. Okay. When you do when you repair something, or you put new components in something, which may actually result in making the item you're trying to repair worse, which is what this seems to be, you need to remember what you've done, and you need to go back to what you've done and see if the components that we're replacing were maybe working better than the ones you put in. I'm pretty sure that is the case. Okay, you have to use, this has a large plate of copper runs along here, and not only is it for common, it's also, I think, for a heat sink, maybe, for the transistors. We got one there, and we got one down there. So those are the two. Is that all I've got? 1, 2, 3. Oh, there's 3 of them. And I think that's all I've got. Is it? Yes. So I've got this transistor, this one, and this one. All right, so I'm going to put this back in. I'll start with this one. Put this one back in, and then we'll see if this solves my problem. If it doesn't, then we'll do this. I actually might put this one back in because it's overvalued, which is not great, but the ESR is okay. So that might mean that that is fine. So yeah, one of the things I ran into is that copper on the back requires a heavier, well, I have my soldering iron set where I want it for most of the things that I do, but when I have something like this that's got a lot of copper in the common side, it results in sucking a lot of heat out. So I'm going to bring out my bigger soldering iron just because it's easier to use this and get that swapped, and we'll be right back. Alright, well that was easy. That soldering iron made real short work of that. So we are ready to see if it made any difference. Come on, there we go. Should have left that on, shouldn't I? I didn't. Come on, you can do it. Well, okay, let's turn this on. It's still dancing. Let's see. Oh, okay. Well, oops. I didn't think about it, but yeah, it's freaking out because I had it in. Okay. Well, I guess I didn't really need to remove this. That seems much more stable now. I had the modulation on. I thought I had it off when I was looking at this. I didn't check. But I think here's what I want to do. I want to get better quality capacitors to put in here. Let's see, what does this say? Frequency 250. Let's see here. Okay, so that's actually not bad. All right, well, I'm going to... all right, so here's what I didn't... I should have checked. Yeah. Okay. I forgot. Well, let's do this. I don't think that's going to be an issue, but I want to, because what I did was, I had my scope connected to this connection here, but I want to take this, back this back off a little bit, and make sure that that's working okay. It's dancing a little bit. And it is off now, right? Interesting. I don't remember it dancing like that. If I disconnect this, so that makes me wonder. I mean, this cord goes to my other signal generator, and it works fine. But let's do that. Put that there. Whoops. Yeah, interesting. So that's very interesting. Why is this dancing? I don't know if I can get in there. Maybe I can. Let's try this. See if that makes any difference. Let's try this. I'm going to try this. Interesting. So, maybe I need to, what do I have? Oh, let me try this, if I can round that up. This is the cord that I made up for my in-circuit capacitor tester. And this had they specified that it should be a certain length and a certain type of cable and all that good stuff. All right. And well, I guess if I were concerned about this, all right, so let's go to, and we are, this is 800 roughly. That's 800 right there. And this is telling me that 793, which says that that's not lined properly. But so let's go to and that's saying 10,000. Whoa, we don't want that. That's too much. Let's go back here. 2,000 what we want. Go there. And that says Well, we're changing. This is off. I'm curious to see how accurate this is. So I'm looking at the frequency down here, and that says 2,000 or 2 megahertz. Yeah, okay, 2 megahertz. And that's very accurate. So what's the gauge say? Yeah, it's not accurate. All right. So it appears that for whatever reason, this cable, not this one, this cable is not great. So this is probably a cheapy China cable, and this is a higher quality cable that I made the end for, and I think I might want to make a second one of these for this. Interesting. So yeah, yeah, it's pretty good. It's actually not bad at all. I'm kind of disappointed. Well, I'm glad I checked things out, because now I know. Actually, let's do this. I want to. So I want it there. So here's what I want to do. I want to check. All right. So that's 1 megahertz. Or, yeah, 2,000 kilohertz or 2 megahertz is what that is. That's 1 megahertz or 2,000 kilohertz. All right, so how accurate are we there? Not terrible. Interesting. All right, so here's what I want to do. I've got this. This is pretty accurate, very close where I want it to be. Okay, so now I've got this on one megahertz. Let's see if, even though this is rather a bit more unstable, let's see how this looks in terms of frequency and how stable it is or isn't. So this is dancing more with this on there, but that frequency seems to be the same as what I was getting out of this. So I guess it's okay. It's not as stable as the other one is, but this doesn't seem to be bouncing around. Let me just zoom in a little bit so you can see. Oops. So down here we can see our frequency. Oh, what did I do? I shorted it. Okay, they don't like that. So that sounds pretty stable. It looks pretty stable there. And of course, if I were to do this, that's going to make it modulate more, make it messier. All right. Yeah, but I think I do want to I want to replace both these capacitors. This one, and the one I put back in here. I want to replace those with better ones. But for now, I think it'll work. I do want to get rid of that one. I think it's probably not all that healthy. It's not doing the filtering job that it probably should be, but I don't see anything horrible there. So once again, I made a mistake though, because I had the modulation on when I was looking at that, and I didn't even think about the fact that that would make that more squirrely. And there's nothing wrong with that. It's just the way it works. Okay, so what I want to do now, and actually I'm going to leave this on, because what I'm going to do, in the past I was using this universal counter, frequency counter. I was using that to align this, but because, actually let's do that. Let's see. Okay, yeah, there we are. Think, brain, think. All right, so let's do this. I want to, trying not to make a mistake, and I'm guilty of that far too often. All right, so that says 1,000. So let's go here, input on you. What's nice about that other DK signal generator is that you can read the frequency that this is set to on something like that. Yeah. So that and that agree. Let me just all right. All right. So this gives me the same measurement as this, which means that I can go either way, I guess. Maybe I will use that. Because that's big. The display on that's a lot larger. I can see it better. All right. So what I'm going to do is I'm going to try to align this, and see how I make out. If I don't, I don't. I don't know if I can't remember. Oh, yes. Where is it? B and C. Okay, yes. One of the things that I've experimented with a little bit is this is a T for B and C connection. And so if I said I want to use this instead of the one that's sitting behind me, or behind there, I couldn't get this adjusted accurately enough, I could connect this to one side and then connect the other connection up to my frequency counter. I've done that before. I have had a tube type signal generator, and I used that setup. But you have to be careful about how you connect things up. And I can't remember what kind of a problem I ran into, but I had to hook it up a certain way in order to get it right. And I just don't remember. All right, so I'm going to play with this, see how far I get, and then I'll see where I go from there, because I really don't know. Put that over there. I won't know until I get done playing with this whether or not I can use this the way I wanted to. If I can get this accurate enough to make me happy, I'll rearrange everything. So what I'm going to do with this, I'm going to dig out the instructions. I'm going to align this and see if I can get this somewhere where I want it to be. And well, no, When I figure out what I've got and what I don't have, then I will come back and I will tell you. All right, I want to go back in for part of this alignment because there are things that, at least one thing that doesn't look right. And along with me making some mistakes, but anyway. Let's go to, actually I'm going to put this up here, so I don't want this to move around. I'm really good at that. All right, let's move in a little bit. Let's see, we want to go, let's see. And it's going to be a lot easier for you to read this if I have it stable. And then, all right, so the first part, they wanted you to, let's take this. All right, we're dealing with this, and they have you start off with doing B. So B setting is between 800 and 2000 kc. So you start there, you get that aligned properly, and then you switch to A, and then you go. I chose between 700 and 350. This was more convenient. They say you should go between 700 and 750. And when you're on this is where things get frustrating. Let me go back let's go back and look at this here. All right, I'm going to read this to you and then I'll show you. All right, yeah, B. All right, so they want you, so you're on this one. This is B. This is B. This is A. And, which you can't see, I'll show you in a minute. Let's see. Now, when I read this, now what they're doing is they're asking you, let me go here. All right, so this is for B and this is for A, and these are the ranges for those two. And what they want you to do is they want you to use radio, tune the radio receiver to a station around 850. Well, what I chose to do was I'm using this, and I have this cable connecting to the output of the RF. So my RF output goes there. I can read the frequency directly. I don't have to use a radio to do this. And what's nice about doing it this way is I don't have to tune a radio between one frequency and then back to the other, then tune this and tune back, and all I have to do is read the frequency that I'm looking to adjust here on there. So when you're playing with this, you can make sure that line is exactly on the line for the frequency you're trying to select. And then you go back here, and so if you're not exactly straight on, then you're not going to get at the accuracy you want. You're not going to get super accurate anyway, because we're not dealing with digital stuff here, we're dealing with analog. All right, so, but anyway, so here's the key that I want you to see. So L2, iron core, that's this core that's inside there. You rotate it, and they tell you which way to go, whether you're above or below the frequency you're trying to get to, or where this is relative to the radio. And they tell you rotate the coil out slightly, or if these conditions exist, rotate the coil out. Then okay, tune to the radio station around 1500. Okay, adjust the trimmer on the small variable capacitor. Well, let's show you. Yes, okay. Let's show you this. And I'm going to have to put some light on this, I guess, because it's dark. All right. Well, I'm looking at this. I'm looking at this part, and those are the same size. But here's what they say. Adjust the trimmer on the small variable capacitor for 0 beat. Well, here's the problem. Based on that, I would be tuning this. This does not work. This one does. Go here. This one says closest to the panel. All right. So we're here, and we're going to, when band A alignment is necessary, proceed as follows. So this is band A, and we're dealing with this frequency range, 250 to 750, and they talk about tuning between 700 and 750. I chose that because they then tell you to go to okay, so first they tell you to adjust this capacitor closest to the panel. That is not the one that adjusts the frequency for the A channel. It doesn't work. You have to use this one. You have to use, well, let's go back here. This is the one you use for A. This is the one you use for B. They've got it reversed here as far as I can tell. So when I was playing with this, I could not get it to do what I wanted it to do, so then I tried the different tuning screw, and I found out that this one works for B, this one works for A, and it's just crazy. So, all right, so we're on A. This is the one I had trouble with before. There's my 350, and I'm going to go up here and go to 700. And looks like I've got to tweak that a little bit more. So I have to get that out of there. Okay, but anyway, so I'm a lot closer to where I was now than I was before, and I'm going to have to we have to tweak that. All right, so anyway, I wanted to show you that because, so 700, yeah, so this is wrong. These two are opposite what they should be. It's this one right here. And so, yeah. All right, so now I want to go back and check. I didn't realize, I didn't think, I thought it was dead on, but oh well. Yeah. So, of course. So, you keep going back and forth till you get what you want. All right. So anyway, that's so close. All right. Oh, it barely requires a touch. Yeah, it's very close. So let's see. Yes. All right. So I've got those balanced. They're close enough. When you're dealing with an analog, you're really pushing it to get it more accurate than that. I don't think. And when you're actually using this, you're going to be lucky to get it that accurate. So anyway, all right, so I'm going to bail out again. I'm going to finish this, but I wanted to show you this, that this description in here is wrong. You saw what I just did. This is the one. It's not the closest to the panel. It's farthest. Oops. I do that right. Okay. So I wrote that down. Farthest from. Farthest from the panel, not closest to. So I'm showing you this. This is what I'm encountering. If you get different results, then I don't know. So so the next thing I have to do is I've got to L3. Okay. So the next thing I want to do is I want to adjust. Yeah. So now this is going to give me the. So this is going to be, and alignment C is necessary, so this is the FM, which is this one up here, C4, and then you've got, or that's L4 actually. Oh, that's right, you've got two things. When you're dealing with, I'm hoping they haven't got this app screwed up. You've got C4, which is just on the side, which is up here. I'll show you that. And that's going to be, so that's C4 right there. And you can't see it. My pencil's disappearing, it's washing out. Alright, so there is, that's C4, and then L4 is up here. This is the tuning here. So I'm going to play with that. Hopefully it all works. And because that's actually pretty accurate now on the two that I just got done doing. I may want to review those again to make sure they're okay. But I'm going to go on and do the FM part, and then I'll go back and check them. The thing about frequency generators is you typically want to run them for a while before you check them to see how accurate they are. If you just turn it on and immediately go to do that, things are going to drift, things are going to change, and you're going to find yourself tweaking this again later, and kind of a pain. So probably if you were going to try to make it as stable as possible when you're aligning it, half an hour maybe. I don't know if they tell me that here. They don't, do they? Okay, they don't tell you. One of the important things is turn the modulation off. The fact that this was on when I checked it today, that probably, where are we? Oh, it's down here. Okay. Let's go down there. All right, so the fact that this is modulation off, the fact that modulation was on this probably explains in part why I had trouble with this. Now, replacing all the out of spec resistors in this was not a bad thing to do. It's a good thing to do, actually. And yes, I do know if I were to put in a new capacitor here and a new capacitor there, I would need to go back through and check this. But what I'm doing right now is I want to see, can I get this accurate enough that I can use just this and not have to use a frequency counter. So far it looks promising. But we'll see. So if I can get it as accurate as what I just showed you, that's going to be golden. I'm going to be golden. That's going to be good. So I'm going to continue on, and I'm going to hopefully not make any more mistakes, and hopefully I don't find any more mistakes in this. We'll see. All right, I'm redoing this because, well, for one thing, when I was doing this alignment, I was tired, and trying to record and trying to do alignments when you're not able to think too clearly is a bad thing to do. I do it far too often, and I regret it. And I wind up redoing some things. So, where I'm at right now is I've done both frequencies for the for the AM. So these are both AM frequencies, 800 through 2 megs, and this is 250 through 800 kilohertz. And then we've got, these are all megacycle or megahertz frequencies. So these are done. These worked. I've got them aligned properly. They seem to be accurate, which is good. But now, now we're dealing with this. But we're starting with this one, and you can't see what I'm pointing to. All right. So this. Oh, let's see. Let's go down a little bit more. All right. This is 88 through 108. And if you go up here, this inner ring starts at 88 and goes to 108, which is there. And so let's go to the instructions regarding aligning that frequency range. Now, this is the end of the AM. I think that was the A channel. So for band C and D, FM radio receiver may be used as follows, and I do have one sitting here. So let's read through this, and they do this very strangely. You've just left the AM. You're into FM. Repeat steps 1, 2, 3, 4 of RF alignment. That does not entirely make mistakes. So let's go back to the last, I don't need you. Let's see here. Come on. Yeah, all right. So this, let's go down here. Let's see. All right, so there we are. All right, so band A, 1. Repeat steps 1, 2, 3, 4 of RF. They just repeated. Anyway, so this is band A. This is AM section. Well, they're saying repeat step 1, but I go to step 1, repeat steps 1 through 2, 3. It doesn't entirely make sense. It works for this part. And then they go down here and you get into this stuff that I've talked about just a moment ago for you. And then without changing the receiver, rotate the RF tuning knob to half the frequency of the station. That worked. That actually worked. So now, though, let's go to this one. All right, here we are. Does that look familiar to you? Repeat steps 1, 2, 3, 4 of RF. Well, if you go back to the beginning of A, it says repeat steps 1, 2, 3, 4 of RF. It makes no sense. Except that, why didn't they say select band D here? Why didn't they put that and get rid of all of this? And then give additional instructions as needed. Alright, so I've chosen, this is the range, 88 through 108. I've chosen 107, and I've chose, and I've adjusted RF tuning knob to the same frequency as the station. So let's go here, over here. Let's see, where are you? Right there. So this right here is 107. That's 106, that's 108. All right, so it's on, let's see, right there. All right, I got interrupted. I'm not exactly sure where I was. So I'm going to try to pick up, oh, by the way, this is 107. I was looking at that line up there, which is not 107. This is 107, and as you can tell, that's pretty well centered, and that's blanking out. I'm assuming you can hear that. So anyway, so let's, all right, so let's go back here. So this right here is a little silver screw that sticks out of the side, and I think I showed you earlier. So that's the one that I've adjusted, and that's how I got my alignment for the 107 correct. Now, so I've got this little radio right here, hiding, where are you? Oops, right there. And so if I do, all right, great. So that is good. The question is, how do I do the second part? Because if you go back here, here's what they tell you. Let's see. I'm looking at the wrong one. Try this. Stop it. All right. So our range is 88 to 108. I'm on 107, and they're saying, and they've repeated this sentence from the AM section completely. It's the only thing they've done is they've changed the coil that you're using. All right. Well, let's check this out. I'm going to go all the way over. Okay. That's the complete range. This is correct for this frequency. So where is the other frequency? Because typically, I mean, so if we go back to the AM, I was on 700 kilocycles, blah, 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 kilohertz, whatever. And then I went from 700 to 350. It worked perfectly, because 350 is half of 700, and that worked exactly the way it was supposed to. I was able to balance between the two. Everything looked good. And there's no chance in the world that I can find a frequency that is half of that. The 107 actually is what I'm using. So how do you align the brass? And so if I go, and it's not even, so if you go down here, they're telling you, okay, if the station is 107, which is where I am right now, and I adjust the RF tuning control to 10.7, adjust the pointer until the 0 beat is heard in the receiver. that works. So let's do that one. Let's see. I want to go to, where am I? Alright, so I'm going to go down here to 10.7. And there it is. I'm sorry. Alright. So I set this to that. This is the FM 10.7. Alright. And if I align my head just right, that line is perfectly there, and you can see that that is indeed, so it's perfect. So I don't really understand, because I thought, well, maybe the so I'm trying to think. Oh, okay, so yeah, I guess we'll line it up, but I don't want to cockeyed. But all right, so we are using two different tuning tuning controls. We're using this one, C4, and on the other one, the C, which is the 10 point. What's the range? 10. Oh yeah, 10 to 11.4. All right. So this frequency is 10 to 11.4. Way less than this, and the tuning is here. So I don't know. And so what frequency is this supposed to be on? I don't know. And the fact that they have a brass coil in there says they want you to adjust that somehow, some way, but the instructions just don't work. So if somebody knows, and there's lots of people out there who know more than I do, but if you know what this should say and how you make this work, I would be delighted. I just don't understand. And you saw me tune this entire range, and there isn't a second spot where this radio responds. There's not another frequency here to which this radio responds, which means I have no way of aligning that brass adjustment. I don't have anything I can do with that. So I mean, this, outside of the fact that they changed this coil, this is the exact same thing as they did in the last section of the AM adjustment. And that worked perfectly. Following those instructions got you where you needed to go. Half the frequency of the AM at 700 down to 350, that worked. But here, there's no way you can get halfway. I mean, half of the frequency. So I've got this set to 107. So so what is that, 53.5, something like that? If my math is right. It doesn't matter. This is your lowest frequency. This is only, the range is 20. In order to go half the frequency, you've got to get down in the 50s. This doesn't have any frequencies lower than 88. So how do you use that? I don't know. So here's where I'm at. I got the 107, as you can tell, it's silent at the 107 frequencies. I've got it aligned. And all I can say is I'm kind of glad that, let's see here. Okay, let's see. Are we going to get in trouble? Hope not. Oh, we don't need you. All right. So we're going to just take a quick look at this. Oops. Ah. Okay. Let me do this also. Let's see. So there's our brass insert right there. And there's the other adjustment right here. The only thing I can think of is that if you couldn't get this adjusted properly for that frequency with one of these, maybe you'd have to adjust the other one. I don't know. All I can say is that this service manual information is not good. So anyway, at this point, though, I've done everything I can do with this, and I really do think that this is ready to go. I just did a final quick paint job on the inside lip of this, and once that's dried enough, I'm going to put this in it. I'm going to put this up here somewhere, and then I'm going to figure out, well, then I'm just use it and play around with it and see if it does what I want. But yeah, it's just, this thing has been crazy, actually. It's been just so bizarre, and I don't understand. And they've got instructions backward. There have been a number of other things in the instructions for this that are just plain wrong. So yeah, you have to pay attention with this thing because it can give you headaches. And I don't enjoy that. Not fun when something gives you headaches. Alright, so I am actually going to wrap this up. I'm going to, actually I got to finish painting that properly. I forgot to paint the inside surface of the front of this. So I'll have to clean that up and spray some paint on that. Then I can put it together, and then I can try to use it for things and see how it goes. It'll be interesting to see how useful this is. As I said previously, by the way, my universal counter won't go up as high as this will. That counter, this thing right here, I didn't look at the what that's capable of reading, but I found out that it doesn't matter. It says this is a 150 megahertz universal counter, but when I try to get that to read the range between 88 and 108, that thing goes deaf. It doesn't hear this. But this is working, as I can tell from this radio. So, kind of puzzled. But it's, like I said, I'm going to play around with this. I think it's kind of an interesting unit. It's kind of fun to play with. And if I ultimately decide this is not what I want to keep, then I've got it working. I think it's working right now. And And at that point, I can send it on down the road with somebody else. I don't think it'll be a big deal. Somebody might be interested in this. The only downside to this is when I try to sell this, I may not be able to get out of this what I've got in it. So, you know, I'm going to pay more attention, I think, with that to that down the road. But I did enjoy playing with this. It was interesting. That's why I bought it. I was very interested in it. I thought it was capable of doing more than it can, at least at this point. The thing that turn you off. The thing that I've said this before, but I don't know if others will have seen the previous videos on this, so I'll mention this again. There's two ways you can test transistors: in circuit and out. Also, I'll say this again too. Make sure that you aren't testing your small signal transistors with this in the power position, because that would do a nice job of terminating your transistors that you're trying to test. So, and it's got leakage, it's got beta, which is kind of handy. It's analog, so it's not going to be real precise, although it was close, very close to my digital meters that were telling me what the beta was on that transistor I was testing with. So it works well. The meter seems to be working well. Alright, so back to this. You'll notice this has 1.5 all the way up to 15 volts. And it's a pretty standard voltages here. 3, 4.5, 6 volts auto. This is higher current. 9 volts, 10.5, 12 volts auto, which means you're powering an automotive radio, and then 15 volts. So there's a fair number of voltages that you can use with transistor radios. And if you're able to power the radio from here, then you can do an in-circuit test. If you can't power them from here and using these voltages, then you have to keep it in the out position and just test either here or here on this little socket. So that's the one thing I didn't realize, was that for some radios, a lot of transistor radios, they have their own AC power supply, especially the ones that don't use any of these standard voltages. You can't use this in circuit. So I was a little disappointed in that, but who knows, maybe down the road where I find I start playing with transistor radios that I need to do some testing with, then I'll have this. So yeah, I'm going to wrap up at this point, because I think I've got everything working the way I want it to. I think this is working pretty well. I think you saw me playing around with this, and this is a little bit jittery when I use this cable that I've been using forever on my BK Precision. I'm going to have to try to get some alligator clips and make another one of these that maybe will work a little bit better. Well, I'm going to wrap up. This is probably the last thing I will do on this. Anyway, I hope that you enjoyed this last part, and as always, hoping for comments, and if you haven't subscribed, hoping you will, and also hope you'll join me on future videos.